Hi students, today we will learn about two more types of quadrilaterals, squares and rhombi. Rhombi is plural for rhombus. I've also heard it as rhombuses, but I think rhombi is way cooler. So let's learn about these two shapes. So last time we learned about rectangles, and remember a rectangle is a special type of parallelogram. Well, Papa Parallelogram not only had a rectangle child, but had another child called rhombus. So a rhombus is also a special type of parallelogram. It has all the properties of a parallelogram plus two additional ones. When you were little and you learned about rhombus, you probably called it a diamond. This is what a rhombus looks like. So the properties that it gets from parallelogram is that opposite sides are parallel. Okay, so that means we've got some same side interior angles that are supplementary. We might have some alternate interior angles that are congruent. We also know that opposite sides are congruent, and not only are opposite sides congruent, but they're all congruent to each other. So that is something special about a rhombus. All four sides are congruent. Opposite angles are congruent. So this angle and this angle, and then this angle and this angle. Diagonals bisect each other. Let me sketch those in real quick. So just like a parallelogram, the diagonals have different lengths, but they still bisect each other. So these two halves are congruent, and these two halves are also congruent. And then consecutive angles are supplementary. So this angle over here and this angle over here, for example, they add up to 180. And consecutive angles in a rhombus are a lot like consecutive angles in a parallelogram. One will be acute, one will be obtuse, and they'll always add up to 180. So the two additional properties that are unique to just rhombus are these. One, the diagonals are perpendicular. Remember the symbol for perpendicular? It's an upside down capital T, and that means the diagonals intersect each other at a right angle. So there are four right angles right there where they intersect. Another property that is unique to a rhombus is that diagonals bisect angles, or are angle bisectors. And so this is not true of parallelogram or rectangle, but what that means is, and let me get a different color so you can see it a little bit better, we'll do blue, is that this angle, we'll do three arcs. This angle and this angle are congruent, and they're congruent to these two angles. And then the same is true for the other angles that were formed by the other diagonal. And I'm just running out of lines here, so let me just use another color. I'm going to use purple. This angle is congruent to this angle, and this angle is congruent to this angle. Okay, so these are unique. We're going to try to use these properties to solve some problems. But one thing that's kind of cool about rhombus is that the diagonals divide the rhombus up into four congruent right triangles. Okay, they all have the same side lengths and angle measures. So they are congruent. They are reflections or rotations of one another. Let's try some problems. All right, in both of these examples, it says we have a rhombus. So that's good to know. It's good to know what type of shape you have. Don't go by looks, because sometimes these quadrilaterals can look like one shape, but because of their properties, they're actually another shape. So the first one it says is the measure, if the measure of angle RST is 67, so that's this angle right here, okay? Find the measure of RSW. So RSW is this angle here. And because diagonals bisect those angles they intersect, I know that that is half of the whole angle because these two sides are congruent. So all we have to do to find the measure of angle RSW is to take 67 and divide it by 2, which is going to give us 33.5 degrees for that angle. Just cut it in half. There's that one. All right. The next one, it says, find the measure of SVT, that's this angle here, if the measure of STV, that's this angle here, is 135. 135 degrees. Okay, so I want you to remember, this angle and this angle are consecutive, so they add up to 180. Okay? If they add up to 180, then the measure of RVT, which is these two together, is going to add with the 135 to equal 180. So it's going to have to be 45 degrees. So that red angle right there is 45 degrees. But the angle we're trying to find, this little guy, is half of that. So the measure of angle SVT is going to be half of the 45, or 45 divided by 2, which is 22.5 degrees. There you go. You can also think of this as another way. So remember, again, if you look at the right triangle, right? I'm going to redraw it real quick just so you could see it. And I'm looking at this one, WTV, right? Remember, there's a right angle here. The diagonals make right angles, right? So this angle up here is going to be half of the 135. So it's going to be 67.5 degrees. So to find this angle here, remember, it's going to add with the 67.5 plus the 90 to equal 180. So you could add 90 plus 67.5 to get 157.5. Subtract that from 180, and then you'll still get the 22.5. So there's a couple different ways you could think about this problem. Let me know if you have any questions about that problem. All right, here are a few more. The measure of SWT, that's this angle here, which I know is 90 degrees, equals this expression 2x plus 8. So basically they're equivalent. So 2x plus 8 equals 90. And then you just solve. So to solve this equation, we're going to first move all our constants to the right side, since our x's are already on the left. So subtract 8 from both sides. We get 2x equals 82. And then we'll divide both sides by 2. And x equals 41. There's example 3. All right, example 4. What's the value of x if the measure of angle WRV, that's this angle, is 5x plus 5, and the measure of angle WRS, that's this angle, is the measure 7x minus 19. Well, we know those two angles are congruent because the diagonal right here bisected this larger angle. So we're going to set these equal to each other. 7x minus 19 equals 5x plus 5. And then we're going to solve. We're going to first move our x's to one side. I want to move them to the left. So I'm going to subtract 5x from both sides. So we get 2x, 7x minus 5x is 2x, minus 19 equals 5. And then I'm going to move my constants to the right by adding 19 to both sides. I'm going to come up here. So I've got 2x on the left equals 5 plus 19, which is 24 on the right. And then we'll divide both sides by that 2. So x equals 12. There's the value of x. All right, so remember how all these angles are working together with a rhombus. All right, now let's do some with diagonals. So this one has 3 parts. It says we have a rhombus. That's important to note. It says that DM equals 26. So this diagonal right here is 26, has a length of 26. It says determine whether each statement is true or false. So A says OM equals 13. OM is going to be half of dm because the diagonals bisect each other. That's a property from parallelogram. So if the whole thing's 26, yes, each half is 13. This is true. All right. B, MD, which is that diagonal, is equal to PL, which is the other diagonal. Not true at all. Diagonals do not equal each other in a rhombus or a parallelogram. So this is false. In a rectangle, yes, the diagonals are equal, but not in a rhombus or a parallelogram. All right, then it says the measure of angle DLO, that's this angle, is equal to the measure of angle LDO, that's this angle. That is not true. In a rectangle, those would be congruent, not in a rhombus or a parallelogram. Okay, those actually are going to add up to 90 because I've got a right triangle, and the two acute angles in a right triangle add up to 90. But they're not going to be congruent. This is not true. Now, in some of our shapes, they are going to be true. All right, write down any questions you have about either of these that you're not understanding. We're going to go ahead and take a look now at square. So Papa Parallelogram, he had a rectangle and a rhombus as his kids. Rectangle and rhombus, they had a kid. Little unconventional, but their kid is square. So square is also a special type of parallelogram, and it's a special type of rhombus and a special type of rectangle. It's all three at the same time. So it's going to have all of the properties in addition, all the properties of a parallelogram in addition to those of a rectangle, and this should say rhombus, and a rhombus. So let's think of what all those properties are. All right, so square has 8 properties. A square, I think we all know what a square is. It's probably what we're most familiar with. Let me also sketch in the diagonals. Square is actually the easiest shape to work with because it's so freaking symmetrical. We'll look at its axis of symmetries in just a minute. Let's look at the properties it gets from parallelogram. Opposite sides are parallel. Opposite sides are congruent. And because square is the son of, or the offspring of a rhombus, all 4 sides are also going to be congruent, right? All 4. Opposite angles are congruent. Now, just like a rectangle, because it's getting properties from rectangle as well, those opposite angles are not only congruent, but they're right angles. So we've got 4 right angles there. Diagonals bisect each other. And not only do they bisect each other, but they're also congruent because that's what it gets from a rectangle, right? So if I have congruent diagonals that bisect each other, then I've got 4 congruent halves, just like a rectangle. Consecutive angles are congruent. Sorry, not congruent. I miswrote that. This should say supplementary, excuse me. Consecutive angles are supplementary, and that's because they both equal 90, so those are going to add up to 180, of course. Then we get into the properties of a rhombus. Diagonals are angle bisectors. So here's the deal. Because each angle is 90 and the diagonals bisect them, that means these little angles are all 45. And that's important to remember. It makes things real easy. Okay. We also know that diagonals are perpendicular. So we've got these right angles in the middle here. And of course we know the diagonals are congruent because it gets that from rectangles. So if you look at a square, the diagonals break it up into 4 isosceles right triangles. So we have a 90 degree and 2 45s in each of these right triangles, and they're all congruent. Very, very simple to work with. Let's try some problems. Okay, for this example, it says we have a square. Okay, sometimes in pictures, squares and rhombuses can look really similar, so make sure you know exactly which type of shape you're talking about. All right, it says if MA equals 8, that's this top side, then HT, which is below it, all sides are congruent, right? HT must also equal 8. All right. It says if the measure of, or it says what is the measure of angle HST? HST is this angle, and we know that that's a right angle, so it equals 90 degrees. All right, the measure of angle MAT is this little guy, is this right angle here. That's also 90 degrees. And then I'm going to take the 8 off real quick because it may affect our last one. But the last one says if HS equals 2, that's this half of this diagonal, then HA, the whole diagonal, is going to equal 2 2's because we have all these congruent halves. The other diagonal also has 2 equal congruent halves, so those are 2 as well. So HA is going to be 4, and MT is also going to have a length of 4 because diagonals are congruent. Pretty simple. And here's our last example. It says use square ABCD. So we know we have a square. And these look like they are dealing with angle measures. So it's either going to be 45 or 90, right? So it says, A says if the measure of angle AED equals 5x plus 5, that's this angle, we know it's a right angle. Find x, so we can say that 5x plus 5 equals 90. And then we can solve that for x. We'll subtract 5 from both sides to get the constants on the right. 5x equals 90 minus 5 is 85. And then we'll divide both sides by 5. So x equals 17 for part A. All right. B says if the measure of angle BAC, that's this angle here, is 5x, find x. Well, that angle equals 45 degrees. So we're going to set the 5x equal to 45. Very simple equation to solve. Divide both sides by 5. And x equals 9. So square is real easy to work with. You only have angles that are 45 or 90, and then almost all of your segments are probably congruent or a half of another. All right, write down any questions you have. I'll see you in class.